I want to talk to you about why functional safety management is so important. So if the company comes under the COMA requirements or the OSHA requirements here in the US, then the company is expected to follow what's known as Regigigap, recognized and generally accepted good engineering practice. OSHA recognizes the IEC 61511 and the ISA 61511 as being Regigigap. So Regigigap is allowing us to follow best practice, if you like. So the purpose of this is to ensure that problems of the past haven't been recreated when it comes to the safety instrumented system. So basically IEC 61511 is based around a safety life cycle, and there are three phases. There's an analysis phase, a design and implementation, and an operation and maintenance. So it's important that we understand the requirements of each of these phases. As I said, we want to try and avoid some of the problems of the past. We want to provide a consistent framework for us to be able to identify and, of course, mitigate risks posed by the operations and the process. IEC 61511 is a performance-based standard as well as being a risk-based standard. So a performance-based standard says this is what you have to do, but how you do it is entirely up to you as long as you can measure your performance, as opposed to a prescriptive standard that will say this is what you have to do and this is how you do it. You have no leeway, no choice. You have to follow it if you're going to be compliant with that particular prescriptive standard. So we want to be able to identify and mitigate the risks posed by our process, and therefore we need to have some targets, some tolerable risk targets that need to be identified. It gives us the ability to achieve an optimum design by following the life cycle. So it's a balancing. We balance out. Initially at the front end there might be some increased costs because we're spending more time and doing the analysis, but at the back end we will gain because we'll have potentially less downtime, less problems, less potential for incidents, near misses and so on. So it does actually balance out at the end of the day. And it gives us a means for being consistent, and being consistent is very important. So if we look at the life cycle, as I said, there are the three phases: the analysis phase, the design and implementation, and the operation and maintenance. And what you'll see to the left side of this particular diagram is something defined as the management of functional safety as well as the planning. So I like to characterize things fairly simply, and the way I characterize functional safety management is the glue that holds it all together. So if we don't follow functional safety management, then we could become unstuck quite quickly. And therefore it's very important, and it covers the entire life cycle. Those of us that have been in engineering are familiar with the 20-20-20 rule. 20 weeks in design, 20 months in implementation, 20 years in operation. So we will be spending the majority of the lifetime of the safety instrumented system in the operation and maintenance phase, which means we can do all the things right at the front end. We can do the risk analysis, we can define what our safety instrumented system needs in terms of safety instrumented functions and the target SIL levels that they have to achieve to reduce and mitigate the risk. And we can do all of that correctly and design it, implement it, we're great. But if we don't do the operation and maintenance side properly, then very quickly our performance will degrade. The planning aspect is very important because we need to be able to define a plan for how we're going to maintain functional safety for the safety instrumented system. So this is a very important part of the overall life cycle. And again, the primary purpose is to help us build safer systems that don't suffer from some of the problems we've had in the past. And it's interesting because a lot of the times when I talk to companies, they think that this is an unnecessary overhead. It costs so much money. But again, Yes, it may cost you at the front end, but if it saves you at the back end because you're not going to be in a position where you could potentially have some serious incidences. And dear old Trevor Kletz, who's sadly no longer with us, is known as the grandfather of safety. He used to say, if you think safety is expensive, try an accident. Accidents can be very costly, not just in terms of the equipment costs or the downtime, the lost revenue, but also if there are fatalities and if there are releases. So there can be all sorts of litigation and fines that could be levied. So we want to be able to build more cost-effective systems that match the design with the risk. Again, it's this balance, and eliminate weak link designs that don't really give us much but could potentially cost us a lot of money.